Well, by now you might be beginning to wonder, how long is this section of the book on line integrals? And then if you're really into lame jokes, you could even say something like, will our work here ever be done? Because remember, this is the line integral for work. And this notation is frequently used in books as sort of our formula for this. But if you've been tuned in, both through my both types of videos I'm generating, you will note that I do prefer writing this vector field dot product velocity vector with respect to time. So it looks more like something the traditional math student could sink their teeth into and sort of evaluate. So here's what we're given. Vector field, first component x plus 1, second component is y squared. And we have a path or a curve, r of t equals t squared comma t. And we're going to evaluate it from t goes from 0 to 2. And this is not a requirement in my directions here, but if you're curious, what you'd be looking at here is along the square root graph from time is 0, time is 2, 2 squared would be 4. It would be from here to here, from the origin to that point. So how much work does this vector field do on a point moving along that particular path? Both the vector field and the path are probably not very good examples of real life physics going on here, but they are good examples just to wrap your mind around how does this calculation work. So let me just slide it up a little bit here. I am going to need to convert the vector field from x's and y's into the variable t, and I need the velocity vector. So there's a couple ways I can do that. Vector field is going to become x plus 1, but I can see here on this particular path x is t squared, so that will be t squared plus 1. Y component is t, so y squared would be t squared also. The velocity vector is the first derivative of the position, so that's going to be 2t comma 1. I now have enough to set up my definite integral. Work equals, from time goes from 0 to 2, t squared plus 1 comma t squared, dot product, 2t comma 1 with respect to t. A little dot product calculation here. 0 to 2, 2t times t squared is 2t cubed. 2t times 1 is 2t. 1 times t squared is t squared. Just a polynomial. That's not so bad. And one quick little power rule later. And 2t to the 4th over 4 is t to the 4th over 2 plus t squared plus t to the 3rd divided by 3, where t is evaluated from 0 to 2. All right, do we have a little bit more in this to do some arithmetic? 16 divided by 2 is 8. 2 squared is 4. 8/3. And I believe, I'm not writing an equal sign because it just didn't fit nicely here, but I believe you would find out here, we would have 12, which is 36 thirds, 8 thirds, 44 thirds would be our calculation for work. Newton meters or foot pounds. The units were not provided, so I cannot provide them back to you. All right, hopefully that wasn't too bad. Keep watching, and remember, you have a pause button. You should try to work ahead of me on something this simple. Not wait for me, but to fill in the blanks and then use this as a check. You can do it. Keep it up, folks.